You know, it's kind of wild when you think about it. We've got these incredible AIs that can compose poetry, paint masterpieces, and churn out perfect code. But then you give them a simple little logic problem, something a kid could solve, and they just fall flat on their face. It's this bizarre paradox, and the key to unlocking it, it turns out, wasn't about more power or more data. It was about a simple, powerful idea from one single research paper. And today, we are going deep on that paper to see how it completely changed the game.
So let's just start with a super simple example. A cafeteria has 23 apples. They use 20 for lunch, then they buy 6 more. You and I, we do this in our heads instantly, right? 23 minus 20 is 3. Add 6, you get 9. Easy. So what does a massive, state-of-the-art language model with billions of parameters come up with?
It says the answer is 27. And it says it with so much confidence. But it's completely wrong. This right here, this is the mystery. How can something so smart, something that's read basically the entire internet, get this so wrong? Well, that one incorrect answer kicked off a whole revolution in how we talk to AIs.
So, how did researchers crack this nut? We're going to break down the paper that introduced this idea of chain of thought prompting. First, we'll look at this weird paradox with these super smart machines. Then, we'll see how we can actually teach them to think step by step, and I'll show you the simple, and I mean simple, trick that unlocked it all. Let's get into it.
So what was going on here? For a long time, the thinking in AI was pretty straightforward. If you want a smarter model, just make it bigger, feed it more data, throw more computers at it. But as this paper shows, that whole strategy was hitting a wall. Just making the models bigger wasn't fixing these really basic reasoning problems. The AIs were getting better at sounding human, but they weren't getting any better at thinking logically.
Yeah, the problem wasn't about the size. It was about the process. See, at its heart, a large language model is really just a super fancy next word predictor. It's trained to find the most likely string of words to follow a prompt. So when it sees that apple problem, it's not actually thinking. It's just making a statistical guess, a leap to a number that seems plausible, like 27, without ever doing the actual math.
The researchers behind this paper, they had this absolutely brilliant insight. The secret to making an AI reason better wasn't buried in some complex new algorithm. Nope, the clue is right there in front of us in how we think. When you or I get a multi-step problem, we don't just jump to the final answer, we break it down.
Think back to your math class in school. How many times did your teacher say this? Show your work. They didn't just want the answer. They wanted to see the process, the logic, the steps you took to get there. Well, it turns out that one simple command, show your work, is the entire key to unlocking reasoning in AI.
And that brings us to the big idea, what the paper calls a chain of thought. It's not code, it's not a complicated formula. It's just a series of simple, logical steps written out in plain English that walk through a problem from beginning to end before giving the final answer.
Okay, now here's where things get really cool. The researchers realized they didn't have to rebuild these giant models. They didn't have to retrain them. All they had to do was change how they asked the question. It is such a simple trick, but it was an absolute game changer.
And here it is, the aha moment. On the left, you've got the standard way of asking. You ask the question, you get a wrong answer. But look at the right. This is chain of thought prompting. The researchers didn't just ask the question. They gave the model a few examples first where they showed their work, breaking down a similar problem step by step. And just by showing it the process of reasoning, the model figures out how to think it through. And boom, it gets the right answer, 9.
I really want to drive this point home. Nothing about the AI model itself was changed. No expensive, time-consuming retraining. This worked on the exact same models that were failing before. The breakthrough was just in how we talk to it. It was about teaching it to think before it answers.
And the results were just staggering. I mean, look at this. On a really tough math test, Google's huge PAL model got a pretty terrible score of 18% when asked the standard way. But you give it a chain of thought prompt, its score skyrockets to 57%. Get this, it even beat a version of GPT-3 that was specially trained and fine-tuned to solve these exact kinds of math problems, just by asking a better question.
This massive discovery led to an even bigger realization. This ability for an AI to reason, it's not something that just gets a little better as the models get bigger. No, it's what the paper calls an emergent skill.
So what's an emergent ability? It's a skill that basically just switches on once a model gets big enough. Think of it like this. A single water molecule isn't wet. A few of them aren't wet. But you get enough of them together, and suddenly the property of wetness emerges. It's the same idea here. Smaller models just couldn't do this kind of reasoning, and then bam, at a massive scale, the ability just appeared.
And you can literally see this happening on this chart. For the smaller models, chain of thought barely makes a dent. But look what happens when you cross that threshold, around 100 billion parameters or so. The performance just explodes. It's like a switch was flipped. The ability to reason wasn't learned gradually. It just emerged when the model got big enough.
And you might be thinking, okay, great, it can do math word problems. But this isn't some one-trick pony. This same technique unlocks really sophisticated reasoning in all sorts of different areas, from common sense puzzles to symbolic logic.
So let's test its common sense, right? Is this sentence plausible? João Moutinho caught the screen pass in the NFC Championship. Now, to get this right, the AI has to connect knowledge from two totally different worlds, European soccer and American football.
And check this out. It nails it. Step 1, it correctly identifies João Moutinho as a soccer player. Step 2, it knows the NFC Championship is American football. Step 3, it sees the mismatch and correctly says, nope, that's not plausible. This isn't just spitting back facts, it's connecting dots. It's real multi-step reasoning.
All right, let's try something different. A symbolic task. These are famously hard for language models because they have to play with the structure of words, not just their meaning. So take the last letters of the words in Lady Gaga and concatenate them. Let's see.
And again, a perfect step-by-step execution. It identifies the last letter of Lady is Y, it finds the last letter of Gaga is A, and it puts them together to get Ya. It's incredible. It shows it can handle abstract tasks just by being shown how to think through them.
Now, of course, this isn't magic. It's not a silver bullet, and the paper is really upfront about the limitations. First, this trick really only kicks in for those huge 100 billion parameter plus models. Second, just because it shows its work doesn't mean the work is always right. It can still make mistakes or just make things up. And finally, if a model just plain doesn't know something, no amount of prompting is going to fix that fundamental knowledge gap.
So, what's the big picture here? What did this all mean for the world of AI? Well, this paper fundamentally changed our relationship with these systems. It was a genuine turning point for the whole field.
And that leads us to the most important takeaway of all. The future of AI isn't just a race to build bigger and bigger machines. It's about learning how to talk to them, how to interact with them. This paper proved that the way we prompt an AI, the way we ask our questions, is just as crucial as the AI's code itself. It shifted our job from just being engineers to also being teachers and conversation designers.
And that leaves us with this really exciting question to chew on. Chain of thought unlocked a powerful reasoning ability that was hiding there all along. It just makes you wonder, what other amazing skills are lying dormant inside these complex AIs, just waiting for someone to find the right words, the right question to wake them up?